Hi guys, welcome to Unit 3, Lesson 7, Sides of Similar Figures. So first off, let's talk about what does similar mean in math, okay? Specifically when it comes to like geometry. Similar describes two figures that have equal corresponding angle measures and proportional sides. So basically, it's like two shapes are similar if it's the exact same shape, just a different size or two different sizes, okay? But all of the angles are the same, equal corresponding angles, and proportional sides. So like every side gets stretched by the same amount, okay? That's what that's referring to. So maybe you remember work with like scale drawings and stuff like that. That's what this is. Now, that being said, let's get into some examples. The best way to look at this is just to start practicing. So this is number 1 from your practice. The two quadrilaterals are similar. So they're telling us right off the bat, these are similar. What is the value of x? Okay, so all of the angles are the same. We're not going to worry about those right now. What we need to focus on are the side lengths. So if the corresponding sides are like this side here matches up with this side here. Now these happen to be in the same position. They're not always going to be like that. So just be aware. Sometimes they'll be rotated. Sometimes it might be reflected. It doesn't mean that they're not similar, okay? Especially if those side lengths are proportional. So what we need to do, now I've said proportional multiple times, like even just since I started this video, right? So we have to use our brains to go back to and think, ooh, what is a proportion? How do I set it up? And how do I solve? So one thing we can do is we can set it up and say, okay, for my little figure, like this one, right? I can say we've got side 2 and 5. So I've got my shorter side, longer side. Shorter side, longer side. Well, remember, in a proportion, you have to have both sides of the proportion set up the same. So if I have the little side over the bigger side, that means over here I need to have the littler side over the bigger side. So I would have 3.6 over x. Okay, so little and little, little and little, longer and longer, longer and longer. So both sides of my proportion are set up the same. Now I can just solve for x. Sometimes you might be able to see, how did I jump from one side to the other? Kind of treat them like equivalent fractions. In this case, I don't know what I need to multiply 2 by to get to 3.6. So I'm going to use the foolproof way of cross multiplication. So, and this is discussed in your lesson as well, okay? So, but they use variables, so just be aware of that. But what I can do is I can say, okay, if these are equal to each other, then I can say 2 times x is equal to 5 times 3.6. And a lot of this comes back from not only our work with proportions, but also ratios, all the way back to fractions, and treating them like equivalent fractions, okay? So, let's see, 5.3, no, just kidding, 5 times 3.6, let's try that. Ooh, that gives me a nice pretty number, I like that. 2x equals 18, okay? So 2x equals 18, well, divide both sides by 2. Whenever you multiply and divide by the same number, they cancel each other out, right? So we've got x equals 9. 18 divided by 2 is 9. So what that tells me is that this side length here is 9, and that would be our final answer. Okay? So not too bad, right? We just have to make sure we recognize which sides are corresponding, or like which ones go together, which ones match up in both shapes. Okay, number 2, which is taken from number 5 on your practice. A triangle has sides of lengths, that's kind of worded funny, but whatever. A triangle has side lengths 4.2, 5.7, and 7.2 inches. The smallest side of a similar triangle is 1.4 inches. What are the lengths of the other two sides? So I didn't really give myself much room here, but that's okay. I'm going to use this space up here. So I'm just going to draw a triangle. I have no idea if this is accurate or not. And it's definitely not, but that's okay. We'll say that's 4.2, 5.7, and 7.2. Well, if I draw a similar triangle, but this time the shortest side, right, smallest side, in this other triangle is only 1.4 inches. So I really did not do a good job drawing mine, but the important thing is that we can like line them up, okay? Because now what I can do, I can create two different proportions for these, because I can say, okay, I can compare my shortest side to my second longest side, so 4.2 to 5.7. Well, the shortest side, that means on the other side of my proportion I need to have the shortest side, and then I can just label that as x, and then solve from there, okay? So I'm not worried about this one yet. We're not there yet. Okay? So with that though, then again, there's a bunch of decimals. Meh. I don't know how to get from 4.2 to 1.4 off the top of my head. And that's okay. We have cross multiplication. So we can say 4.2x equals 5.7 times 1.4. Well, let me see what that is. 5.7 times 1.4, that equals 7.98. So 4.2x equals 7.98. Divide both sides by 4.2. Divide by 4.2. That gives me 1.9. So x equals 1.9. That was this side length, right? And it has to match up in the other triangle. Okay, so we got one down. Now let's focus on the other one. I can use this same ratio of 4.2, but this time, or like I can have those two shorter sides in the top of both sides of my proportion, right? Smallest, smallest. But now, instead of the 5.7, I'm going to focus on the longest side. So 7.2. And then I need the longest side, which in this case I'll say is y, just so I'm using a different variable. Okay? And then I can go ahead and solve. So this time, once again, cross multiplication, I've got 4.2x equals, and then I have 7.2 times 1.4. We can solve that. 7.2 times 1.4. That gives us 10.8, so 4.2x equals 10.08. Divide both sides by 4.2. It's the exact same process each time, just different numbers. Those will cancel, and then, oops, not, it was y. Oops, I changed my variable on you guys. I'm so sorry. This should be y. And then divided by 4.2 gives me 2.4. So, coming back up here, this longest side would have been 2.4. In your practice, it asks for like the smaller length and larger length. So that would be 1.9 and 2.4. Okay? But you find those corresponding sides, which sides match up in the similar figures, set them up using cross multiplication, and as long as your proportions match up on each side, you should be able to solve. Okay, number 3, which is also number 3 on your quick check. Triangle CDE is similar to, that's what this means, similar to triangle PQR. CD equals 9 meters, EC equals 15 meters, PQ equals 15 meters. What is the length of RP? Whew, a lot of just like random feeling letters in there. first let's just make, I'm going to make two similar triangles to each other. They might not be the perfect things, but that's okay. The thing that I need to do first is make sure that everything matches up. So let's see here. I'm gonna draw one that kind of looks like that. I'll draw another one that kind of looks like that. So they're not perfect, but hopefully you get the idea. But now what I need to do, and this is really important, and it's important on the order that these are put in. So what this tells me is that if I have this as labeled as C, D, E, these need to be in that same order that that go like with the corresponding angles, right? This tells me that like angle C corresponds to angle P, and then Q, R. So I went in the same order that I did with this first one. So now let's see what information we have. We know that side CD, that's this right here, is 9 meters. We have EC, okay, that's this down here, that's 15 meters. And then PQ is 15, okay? So, and we're looking for RP, we're looking for this guy, okay? That's what we're looking for. So with that, what we can do, we'll do the same thing that we've been working on. I'm going to go, okay, my shorter side over my longer. So 9 over 15 equals my shorter over my longer. So I'd have 15 over, and I'll just say X. Okay, now that I have my proportions set up, I can go ahead and solve. Again, I'm going to use cross multiplication. So I've got 9 times X equals 15 times 15. Okay? So maybe you have that memorized. That would be awesome if you do. But that gives us 9x equals 225. That's a perfect square, so you might have it memorized. Okay? But then with this part here, and the reason why I put mine in my calculator, 9 divided by 9, that's okay. That gives me x by itself. But then I can divide by 9. And that gives me 25. So this right here, or we could say RP, side RP is equal to 25, and in this case they'd be meters. Okay? So that would be your final answer. As always, reach out to me if you need extra support, okay? Otherwise, have an awesome rest of your day.